Hi, my name is Alex Amaya, Senior Technical Marketing Engineer, and I'm here today to demonstrate Lightboard on how EdgeConnect is optimized for multi-cloud. But first, let me start off with setting this up with the challenges. Cloud migration is a very complex configuration, especially when you have various branch locations in different locations, either regionally or globally. Connecting to the cloud service providers such as AWS, Azure, Google, or Oracle requires that we bring the data from the branch locations to the data center, then up through the mediums, either being the MPLS or through the internet. Internet, as we can see, we currently have a firewall provided. But this is very ineffective because when we have data from a branch location, such as in the West Coast in San Francisco, needing to reach something like an AWS instance, we need to be very careful with the regions that we're placing this in. We don't want to send the actual data from the branch location to an AWS region that's located in Virginia, and vice versa. Application performance then also becomes impacted because as you're coming from the branch locations in either locations and funneling through the data center, we need to be able to identify the application and be able to actually steer it to its appropriate locations. In many cases, a lot of the data centers still have private circuits that they're utilizing very ineffectively, and everything gets sent up to these locations, such as Google or Oracle, even Azure, including AWS. Or we might end up sending incorrectly some of the data through the internet, which is very inefficient, to AWS, Azure, Google, or Oracle. This creates application performance needs because, again, we don't want to send branch data locations to further distance AWS regions, and the same goes for the branch locations. Now, this takes me back to backhauling to the data center, which is what a lot of the branch locations are doing. So we're really stressing the data center to rely on the data center's network infrastructure to reach to those points of presence up in those private clouds. What we've done is the ability to zero-touch provision to the branch locations as well as to the data centers, all orchestrated, but also the ability now to deploy to these private clouds such as AWS, Azure, Google, and Oracle, giving us the ability to extend this fabric. We use something called one-click, where with the simplicity of adding the API integrations, in this case, for example, now we can configure an instance to the appropriate region to a VPC or a transit gateway network. More importantly, this is a very simplistic process. It's all done through the orchestrator. So now, instead of backhauling to the data center, we can directly go to the internet and then be able to connect to the nearest transit gateway or the VPC, which is within its region. And the same would go for the branch location. So it's simple and it's automated. In addition to this, now we're improving the application performance because as before in the past, when we were sending the data back to the data center, now all these locations such as the branch and the data center have actually policies in place such as with our business intent overlays and the link bonding policy where we can combine these two in the same at the branch location. We can actually send the same data either back to the data center if we need to backhaul it for applications that are in the data center, or now we can actually break out locally to the actual cloud by using internet breakout, as I've shown here. So this will get us to the closest points of presence in this configuration. As we've done this, I no longer am actually backhauling any of this data and actually using very expensive MPLS circuits to actually reach these particular sites. I'm using actually now more effectively internet connections, such as even consumer grade or DII setups. But in addition to that, I'm actually reducing a lot of the cost here that's associated because we don't want applications such as social media applications using very expensive MPLX circuits. Now we can break that out locally and then send it out to the cloud in this case. Now, these clouds also have, with the connection, the connectivity on the back end to reach some of these SaaS-based applications, which is using a very high-performing bandwidth and with very little latency, so we can get to these applications very instantly and very quickly. And again, this gives us bandwidth cost reduction. Then more importantly, as I look at all of this here, as I'm connecting to these actual instances from the internet or from within MPLS, I have this ruggedized first mile where I'm actually enhancing all the way through as I extend this SD-WAN fabric. I'm actually improving the application performance. I'm also encrypting the data so it's being secured. And then I'm also being able to give our users that quality experience that they expect.